I'll be your instructor for this course, Arduino and IoT. So this course is planned for people who are new to IoT and want to work with more of sensors and learn what IoT is actually. So this course is for you and it is divided into various segments. So first, your Arduino and IoT, it is divided with the basics introduction. So coming to the introduction, we'll be learning installing how to install Arduino IDE on Windows, then installing Arduino IDE on Mac OS, then the Arduino board's specification, and then sensors, what are actuators, how to debug and fix errors in upcoming videos. So next part, we will be learning about Arduino programming. So in Arduino programming, you will learn what are the sketches, that is the structure, the control statements, further syntax, arithmetic operator, then you have comparison operator, boolean operator, pointer access, bitwise operator, compound operator, digital IO, analog IO functions, advanced input-output functions, your time-related functions, math function, trigonometric function, character function, random number function, bits and bytes function, external interrupts, more external interrupts, communication, and USB. So these are the programming related videos what you will be learning. Then coming to your sensors and actuators with Arduino Uno. So you'll be learning the first and the foremost basic onboard LED. Then you'll be understanding how the breadboard works. Then we'll write a blink LED program. Then we'll have an LDR with LED. Then we'll see the temperature sensor LM35. Then we'll see DHT11 sensor. Then we'll see ultrasonic sensor. Then we'll incubate ultrasonic sensor with LED. We'll be using buzzer, soil moisture sensor, water moisture, potentiometer, servo, stepper, a 4x4 keypad, and also Bluetooth module, and then we'll be seeing relay. So there are a lot of sensors that we'll be working on with Arduino. Now coming to mini projects, so we will be whatever sensors we have learned, sensors and actuators, we will be implying them and be creating some mini projects. So first we'll create a wireless bulb control using Bluetooth, and then we'll go ahead a step and we will make it a voice control bulb. Yes. Then after that we will build a wireless car that is using Bluetooth, and then we will have a smart traffic signal. Then after this we'll come to IoT. So in IoT, first you will get a brief introduction of what IoT is, how the IoT wireless and communication works, and what are the criteria. And then once we go ahead with IoT and sensors using Node MCU, we'll be first learning how to set up the Arduino IDE for Node MCU on Mac. Then the same will be taught for Windows. How do you download Blink app? Then how does the onboard LED works for Node MCU? Then you will have Blink LED using Blink app. Then we'll be using relay with Blink server, DHT sensor, servo motor, and also we'll be using smoke sensor. After that we'll go ahead and we'll see how data analytics can be done using ThinkSpeak, and we'll be analyzing temperature, soil moisture. After that we'll go ahead and we'll write our own web application using Google Firebase database. So we'll be writing our own web server, we'll be writing our own web application. Then after that we'll go ahead and we'll learn some basic Python. So we'll learn in introduction, we'll learn what is the data structure in Python, and we'll learn few control statements. After getting an intro about Python, then we'll use Raspberry Pi with sensors and actuators. So first we'll learn how to install Raspberry and OS, and then we'll see Blink LED with RPI, then we'll see relay, then we'll see temperature sensor, ultrasonic servo, and push button with Raspberry Pi. After that we'll go ahead and more advanced and we'll do Raspberry Pi and video processing. So we'll first learn how to install OpenCV library, then we'll learn to capture videos using USB webcam. Then we'll go ahead and we'll use OpenCV and we'll use Har Cascade, and we will classify and we'll be detecting pedestrians from videos. Then we'll be detecting cars and bus. So these are the courses what you will be going along. So these are the things what we'll be learning along in this entire course, and it will help you get an idea of what sensors and actuators are, and how do we work with things, how do we create an IoT application, how do we create our own application. So hope you guys enjoy the course and take the much out of this course. So in this video, I'll be telling you how to download Arduino IDE on your Windows platform. So what you have to do is you have to go ahead and you have to choose your favorite browser. and then you have to type in download Arduino IDE. So once you go and type that and hit enter, so you will have this page. Yes, so you can go ahead and click on the main, that is the first page, that is arduino.cc. so arduino.cc is your main website, the official website where you can get this software set. So the first option you get here is for Arduino's web IDE, but we don't need that, so we need to download it. So you can scroll down and you can go ahead and you can see you have this option called as download the Arduino IDE, and you have it for various versions. So you have seen for Mac OS also, and for Windows you can go ahead and you can download the installer. So I'll go ahead and click this, download the Windows installer. So you get this prompt asking for contribution. So if you don't want to do any contribution, you can just go ahead and click on just download. Okay, and then after that you will see that it starts downloading. So once your Arduino IDE gets downloaded, you can go ahead and you can install it, and also you get the options for drivers. So I'll be showing you that also. Okay, so the downloading is done. So I'll go ahead and I'll double click here, or you can go to your download folders and you can then download it. Okay, so once I double clicked on that, I got this prompt. So I'll just click on I agree, and then after that you should make sure all the options such as install USB driver, everything is being checked, and you can say next, and then let it be in C files, Arduino default, yes, click on next, and then you can go ahead and you can click on show details if you want to see what are the operations that have been performing. So you see it is extracting. So you just have to wait until unless this gets completed, and in between you will be prompted for installing drivers. So I would highly recommend that you have to read carefully and you have to press on install the driver so that it should install the drivers. If you don't click on install, then if drivers are not installed, then it won't recognize your Arduino through USB. So whenever you connect the Arduino or Node MCU via USB, it won't be recognized. Okay, so you can see it is prompting me for the driver. So you see, would you like to install the driver? So I would highly go and recommend that you have to press on install. So you have to press install. If you don't press install, then the drivers won't be installed, and then you will get an errors and lot of bugs while uploading the program. So you see it is completed. So now you can go ahead and you can click on close. So we can just minimize the browser. So now you can see we have your Arduino installed. So you can go ahead and you can double click on this. So it prompts for alert. So you can press on allow access, and then you see we have our Arduino IDE ready. So this is how you install Arduino IDE on Windows platform. Hello guys, so in this video I'll be explaining you how you can download and install Arduino IDE for macOS platform. So you have to go ahead and in browser you have to type here Arduino IDE, and then once you write in Arduino IDE you have to go ahead and click on the first link. So that lands you up to this Arduino's official page. So here if you scroll down, so you will have Arduino IDE. You have a web editor, so if you don't want to download and use a web editor, you can go ahead and you can get started with that, or I would suggest you can go ahead and download an IDE, so whichever version you have. So I'll be downloading it for macOS version. So if you want to contribute you can go ahead, or else I'll just click on just download. Okay, so once I click on that, then as you see it starts getting downloaded. So once it is downloaded, then I'll go ahead and install the Arduino IDE. Okay, so it is downloaded. Now it is decompressing it. So yes, it is done. So now you can see my Arduino is ready. So I can go ahead and Mac users, you have to go to Finder, you have to go to Applications, and then all you have to do is you have to drag and drop that to your applications folder. So I'll have this, I'll drag and I'll drop this to my application folder. So you'll have this Arduino in your application folder. So that is all you have to do. Then you can go ahead and you can select Arduino from here. So because it is first time, it will take some time to load up. It will verify and it load up. Sometimes what happens, this is a third party app, right? So it will prompt for whether you have to open. So you might have to see if it might prompt like this saying it is secure or not. So you can just go ahead and click on open. If you're not getting this open icon, then you can just go ahead to system preferences, and in system preferences you can go to network and settings, security and privacy, and there below you will have the options. Here you will have the option to open anyway, so you can go ahead and you can use that also. So as you can see, my Arduino IDE is loaded up now. So I can go ahead and I can write the program. I can save it from here. If you have to choose boards, you can go ahead to tools and you can from here you can get the boards, all that specifications, everything. So this is how you download Arduino IDE on your macOS systems. Hello guys, so in this video we'll be having a look about Arduino, what are the Arduino boards out there, and what are the boards we will be using and the specification. So let's get started. Now talking about Arduino, it's an open source board that is being used for many engineering projects, building of prototypes and whatnot. So there are dozens and dozens of Arduino boards out there present. So you name it, you have all the size, types and pins of Arduinos available. I have few of them here listed, and this is not all. There are huge numbers of Arduino more boards that are available out there, but we cannot list them all, nor can we use each and every board in our project. So we will be using Arduino Nano, we'll be using Arduino Uno and Mega for major purpose. The reason is these are the common boards that are used in engineering. That is, if you are building some prototype, if you're planning to do some projects, if you're trying to learn what is hardware part. So these are the general board that is being used. People don't use all the boards, they learn with the most basic boards. Now in the further videos, when I will be working with Arduino with various sensors, so these are the boards that I'll be majorly using. So I'll be using majorly Arduino Uno, and I'll be doing few sensors on Arduino Nano and Mega also, so that you know how we use them. So your next question would be, where do I buy them? So yeah, you are free to go ahead and buy this from any local electrical store nearby your house or nearby your place, or you can go ahead and buy this on e-commerce platforms like Amazon, Flipkart. You have many such platforms where you can buy such components and boards from online e-commerce store. And Arduino boards, as you know, it's open source, so there will be various companies selling it, so you'll have various price range also, so make sure to note that. Okay, so getting started, the first and the foremost board, that is the Arduino Uno. So universally this is the most used board in order to learn your IoT or Arduino, working with sensors, engineering project model, because this is the most basic. It has all the requirements. So whatever you need, the pins, the number of pins, the slots, the size, the weight, everything, the processor, the flash, according to everything, this fits best for any small purpose or for the starter to use this board. Now the specification and what about information. So you know the Arduino Uno, it is a microcontroller based board which has an Atmega 320p chipset on it. So this Arduino board, it has 14 digital input and output pins. So when I say digital, it is discrete pins, that is either it can be low or it can be high. Now among these 14 pins, there are 6 pins that are used as PWM. You know what a PWM means, right? So it's a pulse width modulation, and these pins, there are discrete, but the value can range from 0 to 255. 255 being the highest 5 volt and 0 being the least 0 volt. And this Arduino board, it has 6 analog pins. So analog pins, as the word says, it is continuous, so the value may change. So the value changes from 0 to 1023. Now there is a 16 megahertz resonator inbuilt, and you have a USB connection in the Arduino, so that it's easier to connect in your laptop and write a program and burn it in the flash. Also you have a power jack, you have an ICSP header, and you have a reset button. So when you want to restart the program, you want to reset the computation, you have a reset button out there. And also you have an AC to DC adapter, which you can use that in battery to power up the Arduino. Now coming to the technical specification of Arduino. So Arduino, what type of microcontroller does it have? It has an Atmega 328p board. Now what is the operating voltage? So the max voltage the Arduino can give you is 5 volt. What is the input voltage? So when you're trying to give input, if you're not using USB but you're using some battery to give input to the Arduino, so you can give anywhere between 7 to 12 volts of input. Now talking about digital IO pins, how many digital pins are there? So there are 14 digital pins in the Arduino, in which 6 of them are PWM, pulse width modulation pins. So as you can see in the next part, we have PWM pins. We have 6 PWM pins, we have 6 analog pins. Now what is the max DC current given per pin? So 20 milliamps of power is given, max current, it is max current given by per pin, and that is for a 5 volt. Now DC current for a 3.3 volt, it is 50 milliamp. What is the size of memory? So whatever program you write, it gets flashed in memory, right? It gets downloaded and burned in the memory. So what is the max size? So there is max size of 32 KB. So your program can be at max 32 KB in size. Out of this 32 KB, 0.5 KB is used for bootloader, that is for your boot ups. Now what is the static RAM available? You have 2 KB of static RAM and EEP erasable ROM. So you have 1 KB of erasable electronic ROM out there. What is the max clock speed the Arduino can handle? So your Arduino can give a max clock speed of 16 megahertz. Now do we have an inbuilt LED on the Arduino Uno? Yes, we do have an Arduino's inbuilt LED, and that is placed in pin number 13. So what is the length of Arduino Uno? So the length of this Arduino Uno is 68.6 mm, that is nothing but 6.8 centimeter, and the width is 5.3 centimeter, and it weighs around 25 grams, which makes it very light to have it on any other platform. So this was all about your Arduino board and then the specification. Now coming to the application. So where all do we use this? Arduino boards. So Arduino Uno, it is used for do-it-yourself project prototyping. So if you are doing a project, maybe a school, an academic project, or an engineering project, or you're trying to build a prototype to show it to an company or so you can use this Arduino. Now Arduino is also used in developing project based on code-based control. So if you have to control few sensors, if you have to control something based on the program, so you can straight away go and use a Arduino Uno. Arduino Uno, it is also used in automation system. If you want to fetch some sensors data and you have to trigger some actuators, so you can go ahead and use the Arduino. Also it is used for designing the basic circuit design. So if you have some basic circuit to be designed, you can straight away go ahead and use an Arduino board. So these were few slides about Arduino Uno. Next, coming to the next board, that is Arduino Nano. So what is this Arduino Nano? It is a small mini size board. So I can say it is just the half of the Arduino Uno. Now why do we need a board half of the size? Because there are some cases where you're working and you need a smaller board that can fit to your prototype, or you don't need a larger board. So you can go ahead and use an Arduino Nano, or if you need just few digital pins, for that you don't want to buy a bigger one, you want a smaller one, you can go ahead and use an Arduino Nano. So talking about Arduino Nano, it's a small, complete and breadboard friendly board. Now why do we say breadboard friendly board? Because you can see it is so small that it can fit on any breadboard. So it is known as breadboard friendly board, and it has an Atmega 328 chipset. Now you can see it has an Atmega 328P chipset, which is same as the Arduino Uno. Now this has more or less the same functionality as Arduino Duo, that is nothing but the other board out there which is same as your Arduino Nano. The only problem with the, or I can say the only drawback with Arduino Nano is that it lacks a DC power jack. So in your Arduino you can give an external power supply using a battery, but here it lacks that. And this, instead of using a normal USB cable, it uses a mini B type USB cable. So that is nothing but if you have a normal charger USB. Now if you understand by that charger USB what we use, so yes, you can use such USB cables for uploading the programs. Now coming to the specification about the board, so as we know, the microcontroller out there in this is Atmega 320P. What is the operating voltage? So this can give a max of 5 volt. Now what is the flash? Again, it is same as your Atmega 320P and Arduino Uno, it is 32 kb, but in this we have 2 kb of, that is 2 kb is used for bootloader. If you check properly, in Arduino Uno there is 0.5, and in Arduino Nano it is 2 kb that is used for bootloader. What about static rank? It is the same 2 kb. What about the clock speed? It is the exactly same as Arduino Nano, that is 16 megahertz. It has 8 analog pins. If you compare this with Uno has 6 analog pins, but here we have 8 analog pins. About digital pins, it has 22 digital pins, in which 6 of them are PWM pin, pulse width modulation pin. Now as mentioned above, it has 6 PWM modulation pin. What about the power consumption? It takes in 19 milliamp power consumption, this Arduino Mega. What is the size of PCB? It is 18 into 45 mm, that is 1.8 centimeter, that is the width, and the height is 45 centimeter. Now talking about the weight, it is 7 grams. It holds a very small weight, that is 7 grams, and the max input voltage this microcontroller can take is 7 to 12 volts. So this is about the technical specification about the Arduino Nano. Next, coming to the application, where do we use this? So it is used in, again, as you know, it is used in do-it-yourself projects. As we used Arduino Uno, we can use Mega, we can use Nano, the same. The only difference is the number of pins and the size depends. Now it is also used in developing code-based control. So if you have to control few actuators based on some sensor data or so, you can use the Arduino Nano. Now it is used in development of automation system, and it is used in small circuit design. Because of its design, it is used in a small circuit design. Next, we have Arduino Mega. As the word suggests, Mega, this is a big board relatively compared to Arduino Uno and Arduino Nano. Now this Arduino Mega 2560 in particular, it is a microcontroller based which is at Mega 2560. So this has a huge 54 digital input output pins, and in that 54 digital output pins, 15 of them are used for PWM pins, and we have 16 analog inputs in that and 4 UART for serial communication. So if you compare these values, this is way more than the Arduino Uno and Mega. So if you have multiple sensors and actuators connected to one circuit, if you need multiple pins, then you can go ahead and use an Arduino Mega because it has multiple pins. This has a 16 megahertz oscillator. It has a USB connector as the Arduino Uno. It has a power jack. It has everything same as the Arduino Uno, except that it has a powerful chip, and also it has multiple pins compared to the Arduino Uno. Now coming to the technical specification of this board, it has at Mega 328p, that is wrong, it has at Mega 2560. It can operate in 5 volt. The maximum input you can give is 7 to 12 volts. It has 54 digital pins, in which 15 of them are PWM. So we have 15 PWM pins. We have 16 analog pins. Now what is the DC current given by per pin? It is 20 milliamp, and for 3 volt pin it is 50 milliamp. What is the flash size memory? Because this is a relatively huge board, it has 256 KB size of flash memory, in which 8 KB is used for bootloader. Now the static RAM here is 8 KB, which is more than any other board. EPROM is also 4 KBs. We have clock speed same as the Arduino Uno, 16 megahertz. Also this has an inbuilt LED which is at pin 13, and the length you can see it is 10.15 centimeter in length, and the width is 5.3 centimeter, and it weighs around 37 gram, which is more than the Arduino Uno and Mega. Arduino Uno and Nano. So this is relatively bigger board compared to the other two. What are the applications for this? So it has similar application to the Arduino Uno and Mega, but the extra thing is Arduino Mega, it is used when lot of sensors are required to integrate in a single circuit. So these are the application technical specification for the boards. Now talking about the resources, these are the resources for the information whatever I have provided. You can go ahead and you can verify, and also you can go and learn more on this resources. Hello friends, so in this video we'll be talking about sensors and actuators. So what are these jargon words? What does this do? So coming to sensors, a sensor does exactly what its name suggests or indicates. It senses, that is, if there is any parameter that is to be measured. More specifically, a sensor it measures some physical quantity and converts that measurement reading into a digital representation. So reading some physical quantities and converting it into a digital representation is what a sensor does. It senses. Now there are various sensors that we can use in building a prototype or engineering model or a project. Yes, and there are broad classifications for these sensors also. So come, let's look at some of them. So there are few groups of sensors that are basically classified and divided. So the first one is active or passive sensors. So the sensors that can be categorized based on whether they can produce energy and typically require external power supply, or they simply receive energy and they don't require external power supply. So if it needs external power supply, then it is categorized as active, or else the vice versa for the passive sensors. Now there is invasive and non-invasive. So sensors can be categorized based on whether a sensor is part of environment or it is measuring, and invasive or it is external to it. So if it is part of an environment and measuring, so it is invasive. If it is an external, then it is non-invasive. Now coming to the next set of classification, we have contact and no contact. As the name suggests, sensors can be categorized based on whether they require physical contact. That is, if the sensors read physical value upon touching or bringing in contact with the object, then it is in contact. If it is reading the value without in contact, then it comes under the categorization of non-contact. Then we have absolute and relative. So sensors can be even categorized based on whether they can be measured in absolute state or in relative or with reference value. So you have a threshold value, with that you keep measuring, then that is a relative. So absolute means you're completely getting an absolute state, you're completely getting a new value. So based on this, you can group the sensors into any category. So there are various type for various purpose. So let's have a look at few sensors. So first, coming to the position. So what if you have to measure the position? So a position sensor, it measures the position of an object. So we'll be using small sensors like ultrasonic. But if you're going ahead and making a big prototype, you can use a potentiometer, you can use an inclinometer, you can use a proximity sensor. So whenever you're planning to get the position, so these are the sensors what you will be using and which will help you. Coming to the occupancy and motion sensors. So motion sensor is to detect people and detect a motion in the surveillance area. You can use an electric eye, you can use radar. So these are the sensors you should be looking for if you are using motion. Now what if you have to measure the velocity and acceleration? So velocity, it can be linear or it can be angular, indicating how fast the object can be moving, or it is moving along a straight path or it is following a fixed path. So there are accelerometer and gyroscope which you can be using. Now what if you have to measure force? So to measure force, you have various sensors like force gauge, you have viscometer, you have tactile sensors. There are multiple sensors. So if you are planning to read the force, then these are the sensors you will be required to. Now measuring pressure. So how do you measure pressure? So pressure sensors are related to force sensors also, and they are measuring the force applied. So you just need not detect force, but you need to detect the amount of force that is being put on the object, that is the pressure. So you have pressure sensors, you have piezometer, you have barometer, you have multiple sensors which you can use in order to get the pressure. Talking about flow, so when I'm saying flow, it is nothing but detecting the rate of the fluid flow. So for that we have anemometer, you have mass flow sensors, you have wattmeters which you can be using. Okay, coming to the humidity. So if you want to measure the humidity, then you can straight away go and use an DHT sensors. You can use an humistor, you can use an soil moisture sensor to know the humidity beneath the earth surface. You can use an hydrometer to get the specific and very sensitive temperatures. So these are the sensors you'll be looking for if you're trying to verify the humidity. Now coming to detecting light. So how can you detect lights in your surroundings? So you can use an infrared sensors, you can use an LDR for small scale projects, you can use a photo detector. So there are multiple sensors you can use to detect an light. Now to read radiations, so you can have gaseous Miller counters, you have inclinator neuron detectors, and you have multiple sensors which you can use for detecting radiation. Talking about temperatures, so you have temperature sensors, we'll be using DH11, you have LM39, LM35, there are temperature gauge, there are thermometers. So there are multiple sensors you can use in order to measure the temperature. Biosensors deal with measuring or detecting the biological elements such as blood pressure and heartbeat and pulse rate, and also there are various blood glucose biosensors and pulse sensors you can use for that. So there are many sensors that we can use on an engineering model or building a prototype. So few are listed here. So these are the sensors that is used to read the value from the surroundings. So there are various sensors, few of them are listed here which are used day to day in small projects and prototypes. Now coming to the next part, this is actuators. So what is the difference between sensors and actuators? Sensors is used to sense the data, actuators are used to act on it. So actuators are like the complement to the sensors. So they convert the digital representation or digital electrical signal into some real world physical environment, that is into some useful act, maybe some motion or moving or physical effect or some triggers, so on. So this diagram will give you a brief information of what is sensors and what is actuators. So you can see a sensor senses from real world physical environment. So from real world you're converting that parameter or you're converting that form to a digital representations in zeros and ones, in analog values like 0 to 1, 0 to 3. You are having various clock cycles, many things, yes, duty cycles. So you're sensing it and converting it into a digital form. So that is a sensor, what you're seeing at the top, from real world to digital representation. Now coming to an actuator, it is the vice versa. That is, you get the digital representation or the electrical signal based on that you act to do a useful work in the real world physical environment. Say for example, you need a DC motor. So if some automatic doors, yes, so if someone if the sensor sends some human coming forward, so it takes that electrical signal, it takes that physical environment signals and it converts into digital representation and gives it to a microcontroller. Then the microcontroller acts on it. So it uses a DC motor to open the doors, or you can say AC motors to open the door, automatic doors. So that opening of door is nothing but getting the digital representation and acting on some useful real world physical environment. So this is the difference between your sensors and your actuators. So there are also various classifications of actuators. So based on type of motion, you have actuators which can be defined based on type, based on the power consumption, based on whether it is discrete or continuous, area of application where you'll be using it, types of energy that it will be using. So you have example mechanical actuators. So you have lever, screw, you have jack, hand crank. These all are nothing but mechanical actuators. Electrical actuators, you have like bipolar transistor, you have diode, you have capacitor. So things are known as actuators. Now electromechanical, your AC motor, DC motor, stepper motor, the servo motor, what we use, these are known as electromagnetical actuators. Now electromagnetic actuators, as the word suggests, there is magnetic in this. So we have electromagnetic, we have linear solenoid for that. For hydraulic and for pressure, we have hydraulic cylinder, we have pneumatic cylinders, we have piston control valves, we have air motions. So there are various such actuators which are divided based on what kind of act you have to perform to the real world environment. So we'll be using many such sensors and actuators in our coming courses. So these listed are the few sensors what we'll be using. These are the most common sensors or actuators, you can say, that are being used in engineering model, and we will also be using this. And your next question would be, where can I find them, where can I buy them? So again, you can go ahead and you can purchase it from any local electrical store, or you can get it on Amazon, and you can get it on any e-commerce website, Amazon, Flipkart, and you have Robocop. There are many such e-commerce websites where you can get this. Now talking about the resources, so whatever content, the specifications I got it from these websites and books. So you can go ahead and you can, if you want to learn more, you can go ahead to these resources and you can have more brief. Hello guys, so in this video I just want to give a heads up that once you're going through these courses and you're working along with the hardwares and sensors and you're writing along the code whatever I have given, the connections, so not every time it works in one attempt. Sometimes what happens, you do some wrong wire connection. Sometimes the wire what you're using might be not proper, the jumpers what you're using might be not proper. Sometimes what happens, instead of connecting to one pin, you connect it by mistake to the next pin. So there are few things, few cases where what happens, because of this tiny mistakes which is not done on purpose, but still it happens and you don't get output, and many times it is frustrating and also demotivating. So kindly don't get demotivated. Coming to hardware part, it is very important to debug. So many times it happens your hardware doesn't work, or you're sometimes using some extreme high components which you don't get much of an information in the blogs or anywhere. So I'll just say you few tips and tricks how you can just deal with this. So for cases where you're working with sensors which has not been listed here, or you're using some sensors which has been newly deployed, or something old which has not been explained here, so you can always go ahead and you can YouTube and you can read blogs. So you can go ahead and example, you can write YouTube. And now I'll give you an example. You're working with GSM and GSM module, that is making calls and sending SMS through your Arduino. So in that cases, you can just go ahead and you can write here how to use GSM module with Arduino, something like this. So whatever sensor you're trying to use, you can go ahead and write, and then you'll have many such tutorials and step-by-step explanation if you are using something which has not been listed, or you're trying to incubate something in your project, it is not been listed here. Now other cases, what happens is when you're working and suddenly you need some program which has not been listed. Yes, so in that case what you can do is you can just go ahead and you can check for blogs, or you can check for code on GitHub. Say for example, I need a code to run ultrasonic sensor. Yeah, so I'll just write Arduino ultrasonic sensor code. So you just have to write the board and then the sensors, and then yes, see, you will have many such blogs which is give you a step-to-step explanation about your code. So sometimes what happens, you are using some components or some board which is not there, right? So you can just go ahead and you can get many such codes and explanations from many such websites. So you'll have beautiful explanations, also you'll have code with that, so connections, and also you have some codes here, right? So you can go ahead and you can use this code, you can just copy paste, or you can do some changes, you can change the pin, and you can go ahead and you can use this code. So these are some cases where you're working with some sensors that is not being displayed here, or you're using some high-end sensors which is you need the code for it, you're not understanding, or you need to debug, so you have to do this. Now many a times it happens that even if you are installing library, the library doesn't get installed properly, or when you're downloading, or when you're using your custom library, when you're using particularly some sensors which need custom library, if it doesn't work, so don't worry, you just have to go ahead and you have to download it from GitHub. So for example, I'm using an GPS module, and for GPS there is a library called as Tiny GPS. So you just have to write library for Neo GPS sensor. So you will straight away go and have links, you will have GitHub links, you will have Arduino's links. So see, I have all this GPS library tutorials and all. So example, you're using this GSM module, you have explanation of what are the functions that library has, that what is the implementation of library, plus you get the link to download the library. So you can go ahead and download it on even GitHub. You can just write here, you can write your sensor and you can write GitHub. So when you write this, you get the GitHub link for your that particular GPS where you can check the code, you can go ahead and download. So these are the ways you can just go ahead and download the libraries. Now coming to the connection part, many a times it happens that you are doing the same connection what I'm saying, but your output doesn't work for you. So as I listed the reasons, it might be because your wires are not working, or you might have done a tiny small changes in your by mistake you might have connected to some other pin, or you have not connected it properly on breadboard, or sometimes it even happens when you're buying new electronic components, the component doesn't work. We think it's new and it has to work, but the component doesn't work. Few components, they have LED showing us that the LED indicates that okay, power on and off. Other sensors like DHT or whatever we use, it has no LEDs. Directly you have to read data, and if it is not working, you think it is problem of code, library, or your connection, but actually it is the sensor itself. So electronic devices, you can have no guarantee, so sometimes you have to check that also. You should be patient, and you should be able to identify that also. Okay, might be that this is a sensor problem also, that this sensor wherever I have purchased, if it is in warranty, you can go ahead and you can get it replaced, or you can talk to them, or if you have purchased online, you can get it replaced. So there are many things when you're coming to hardware and you're coming to Arduinos and IoT. You have to be patient to learn this, because in this series you will have you have to debug many such errors. You will be learning for the first time, so obviously you will be getting errors. So you have to be patient and you have to debug all this. So the more errors you get, the more you debug, the more you learn. So the next time when you're writing same thing, you will avoid such mistakes, and you will know in prior that okay, these are the things I have to make sure I don't follow again, so that I don't get such errors. So these are the ways, and these are few tips and tricks you have to use when you're working with any projects, when you're working with any hardware, be it any board, IoTs. So you have to make sure you note all this.